Good evening, children. Again, I am back with another very interesting topic, evaluation of artificial intelligence for class 10. This is very important chapter, children. So be with me up to the end of the tutorial, up to the end of my video, and please like and subscribe my channel. Evaluation helps to check whether any model, that is any AI model that has been developed, whether it is actually working or not. That is the actual main motto of the evaluation. So evaluation helps to check whether the model is better than the other one or not. It is also most important part of the development process, because when there is any kind of development of any device or of any AI device, evaluation takes part to check whether the model is actually working up to the requirement or not. So that is the main thing. So it helps to determine the best model for data processing, and it also helps in how well the model will work in future. So actually, when any model has been any AI model will be derived or will be developed, so after the development, the scientist or the engineer, they will first evaluate the model, that whether it will work in future or not, or whether the model is working as per the need or not. So that is the actual main motto of the evaluation. All right. Now come to the next part. Now we have two kinds of data sets. One is training data sets, another is testing data sets. Now when we are evaluating any model, so we have to test two types of things. One is training data sets, another is testing data sets. Training data sets means that during the evaluation, some data we need, the engineers are needed those data for the training purpose. Means when the model has been developed, now they are giving the training to the persons who need that model. Testing data sets means when the evaluation is going on, when the model has been developed, but the model has not been given to the particular company, so they are testing whether the model is working properly or not. So that is testing data sets. So evaluation is the process of understanding the reliability of any AI model based on outputs by feeding the test data set. So what I told you, that the engineers first, they will give some data so to test the model. So those are known as testing data sets, right? So testing data sets into the model and comparing it with the actual answer. So actually the answer is right or wrong, the model is giving the proper answer or not. So that has been done so during the evaluation process. So there can be different evaluation technique. So we will come slowly depending on the type and the purpose of the model. Now the evaluation, the main aim of this model, of any model that has been developed, is to predict whether, for an example, if there is a forest fire has broken out into the forest or not. So any AI model has been derived or has been developed, and that AI model, by the help of that AI model, evaluation is, or the testing is going on, that whether the model is giving the prediction proper or not, that whether the prediction is matching with the actual scenario or not. So to understand whether the model is working properly or not, we need to predict, to check whether the prediction made by the model is correct or not. So there are two conditions. One is the prediction, another is the reality. All right. Now, what is prediction? Prediction means the output given by the machine after the training and testing the data. So what the output is coming from that particular device that has been developed. So that is called prediction. All right. So the output given by the machine after training and testing the data, that is called prediction. Then what is reality? Reality is the real situation, actual situation, the real scenario in the forest. For an example, in the case of forest fire, what is the actual scenario is. So that is called reality. So where the prediction has been made by a machine. All right, so that is called. This chapter is, children, very, very important. So many questions will come, and it is very important. So please study this chapter, read this chapter, practice this chapter thoroughly. Now, first condition. The first condition is prediction is yes, prediction. That particular device, suppose that device is predicting whether there will be forest fire or not. So the first condition is the prediction is yes, but the reality is also yes. Children, this type of question several times will come. So this condition is known as true positive. Why it is called true positive? Remember some small tips I will tell you, children, that if the prediction is yes, blindly you will understand that the positive will come positive. When the prediction is yes, it will be positive. And when prediction and reality, both answers are same, then it will be true. So the answer, this condition is known as true positive. So when the prediction is yes and the reality is also yes, that means the prediction, the device is predicting that there will be a forest fire, and in real scenario there is forest fire. So in both the cases, the answers are yes. So this condition is known as true positive. All right. Next condition, when the prediction is telling no and the reality is also no. When the prediction is no, blindly you will write here negative. When the prediction is no, here it will be negative. And both the answers are same only, so for that reason it will be true. So this condition is known as true negative. So when the prediction is no and the reality is no, so this condition is called true negative. Okay, short question used to come, what is true negative, what is true positive, what is false positive. So all these things short will come, and the children, many times you people are having confusion that when the true negative, when the false negative, when the false positive. So when the prediction is no, blindly here the negative will come, and when both the answers are same, true will come. So in this case, in this condition, it will be true negative. All right. Now next, condition number 3. When the prediction is yes, reality is no. When the prediction is yes, blindly we will write here positive. As I have told you, prediction is yes, so it will be positive. And see, in this case, prediction is yes, reality is no. That means the device is predicting that there will be forest fire, but in reality, in real scenario, there is no fire. So both the answers are not same. When both the answers are not same, so in that case, we will write here false. All right. So prediction is yes, that means positive, and both the answers are not same. For that reason, here false will come. So this condition is known as false positive. FP, false positive. All right. So this condition is called false positive. Condition number 4. Now, when the prediction is no, reality is yes. The device is predicting that there will be no forest fire, but in reality, in real scenario, there is a forest fire. So when prediction is no, blindly we will write here negative, as I have told you. And when the answers means the prediction and the reality, both answers are not same, so here it will be false. When the answers are not same, the answers of prediction and the reality, the answers are not same, in that case it will be false. And when the prediction is no, for that reason here negative will come. So these are the small things by which we can able to remember, how you can remember those things. These are the simple formula. Prediction is no, that means here the negative will come, and when the prediction and the reality answers are not same, so the false will come. So this condition is known as false negative. FN, false negative. All right. Now, confusion matrix. What do you mean by confusion matrix? It is a comparison between the prediction and the reality. Okay, so it is just a comparison. table by which we can able to compare between the prediction and the reality. It helps us to understand the prediction result. It is not an evaluation matrix, but a record that can help in evaluation. So in this table, confusion matrix table, we will do the comparison between the prediction and the reality. So true positive means prediction and the reality are matches with one another. For that reason, true prediction is true, for that reason positive. So true positive. True negative means when the prediction is what? False. For that reason negative has come. And the prediction and the reality both are telling the same answer. For that reason true. So true negative. False positive means the prediction is true. Prediction is true means positive, and prediction and the reality are not matching with each other. Their answers are different. For that reason false. So false positive. And when false negative will come, when the prediction is false. Prediction is false means, always remember children, when the prediction is false means negative. And here false means prediction and the reality answers are not matching with one another. For that reason it is false. So false negative. All right. So confusion matrix, this is the prediction between the, this is our table between the comparison between the prediction and the reality. Now check it out. In this table, see, on the right hand side we are having reality, on the left hand side we are having prediction. All right. So prediction can be yes, can be no. Reality can be yes, can be no. Now check it out. When the prediction is yes and the reality is yes, it is true positive. It is true positive. All right. Now next, when the prediction is no, but when the reality is no and the prediction is yes, so it is false positive. Prediction is yes, so positive, and the answers are not matching with one another, so false. So FP, false positive. All right. Now next, when the prediction is no, so negative, and the reality is yes, so answers are not matching with one another, so false. So false negative. FN. Last one, when the reality is no and the prediction is also no. So prediction no means negative and both answers are same. So true. So true negative. So true positive, false positive, false negative, and true negative. So this is the one of the example of confusion matrix. Question can come, what do you mean by confusion matrix? So you have to write the definition of confusion matrix and you have to draw this table to just explain it about the confusion matrix, the comparison between the prediction and the reality. Now, there are different types of evaluation methods are there. Now, the different methods are accuracy, precision, recall, and F1 score. So these are some of the evaluation methods. Evaluation methods means the engineer or the scientist who has developed that particular AI model, they will evaluate the model, whether the model is working properly or not. So that is called evaluation methods. So the methods are accuracy, precision, recall, and F1 score. So one by one we will discuss. Accuracy means the percentage of the correct prediction out of all the observation. Percentage, because it will, the calculation will be in percent. So it is a percentage of the correct prediction. How many times it is predicting, the device is predicting the correct prediction. All right, that is true positive. How many times? Out of all the observation, it is called accuracy. Now, if the prediction is matches with the reality, then it is said to be correct. All right. So there are two conditions where prediction matches. So one is true positive, another is true negative. There are two methods where prediction match with the reality. Now check it out, the accuracy formula. Children, you have to remember this formula. With the help of this formula only, the one question, and that is compulsory, you have to practice this formula very nicely, thoroughly, because accuracy, recall, precision, F1 score, it will come and it is very important. Accuracy, so the formula is correct prediction by total cases into 100. So the result will come in percent. So TP, true positive, plus TN, true negative, by all the cases. So true positive plus true negative plus false positive plus false negative into 100. So the total observation covers all the possible cases of the prediction. That can be true positive, true negative, false positive, and false negative. Now, accuracy talks about how true the prediction are by the model. Okay, so that is the thing. In the case of forest fire, now see, if the model is always predicting that there is no fire, wherein in the reality maybe 2% chance of forest fire can be there. So 98% the model is telling the right answer, right? And the 2% the model is not telling the right answer. That means true negative is there and true positive is also there. So true positive is 0, true negative is 98. True negative means, children, when the prediction is telling no and the answer is also no, right? So that is true negative. So 98, total cases is 100. So therefore the accuracy is 98 plus 0, because true positive plus true negative by total case into 100. So the 98% is the accuracy of this particular model. All right. Now, next is the precision. Precision means the percentage. It is also, the result will come in percent. The percentage of the true positive cases. How many true positive cases are there? True positive cases means the device is telling positive and the situation is also same, because situation and the reality both are same. For that reason, true positive is coming. So the percentage of the true positive cases versus all the cases where the prediction is true. All the cases where the prediction is true, right? So TP by TP plus FP. When the prediction is telling true, right? So when the prediction means the device is predicting true. When the device is predicting yes. So we have to count only those cases. So TP by true positive by true positive plus false positive. False positive means device is predicting yes, but the reality is no, means reality is something different. So in that is false. So how many times with the help of precision we have to calculate how many times the true positive cases are there versus all the prediction where the prediction is true. So precision equals to true positive by true positive plus false positive into 100. Okay, so in this case also the percent will come. So the precision means, now return to the forest fire example. Assume that the model prediction of the forest fire is irrespective of the reality. So in this case, all the positive condition will be taken. So for that reason, all the positive condition has been taken. Okay. So all the positive condition will be taken into the account. That means true positive and false positive. Okay. Because we have to check it out how many times the device is predicting true. Yes. Okay, so in this case, the firefighters always see if the alarm was true or false. Now, recall the story of the boy, that one story we know from the childhood, that the the child used to cry every time and complains about the wolf, right? So that story. But when the wolf came in reality, no one rescued him. So similarly, in precision also, if the precision is low, means false alarm. That means the device is predicting that is a forest fire, but that is no fire. That means a false alarm. So in that case, then also the firefighters would get the the complacent and might not go and check every time, considering it is a false alarm. Okay, so precision is high means true positive cases are more. So we have to check it out with the help of the device. We have to check it out that the prediction is high or not, means precision is high or not, true positive cases are more or not. So precision is high means true positive cases are more. Okay, so given the lesser false alarm. So when true positive cases are more, obviously that particular device will give lesser amount of false alarm, right? So that means the device is predicting nicely, the device is working nicely. Okay, now recall. Now in the recall method, the the fraction of the positive cases that are correctly identified will be taken into the consideration. What we will take in the case of recall, that true positive by true positive plus false negative. So in the recall method, the fraction, it will come not a percent. Remember, recall will not come in percent by percent, but it will come in fraction. So in the recall method, the fraction of positive cases that are correctly identified will be taken into consideration. Means which are the cases that the device has been correctly identified. Okay, as simple as that. So it majorly takes into account the true reality cases, where in reality there was a fire, but the machine either detected it correctly or not. Okay, so that is the consideration in case of recall. So it considers true positive and false negative. So the formula of recall is TP by TP plus Fn. So that is a fraction will come. So as we have observed that the numerator in both the precision and the recall, the numerator are same. See, numerator are same, TP. Okay, TP. Okay. So in the both cases, the numerator of precision and recall are same, that is true positive, wherein the denominator of the precision count the false positive, while the recall count the false negative. See, here we are taking false negative. In the case of precision, we have taken false positive. Okay, so that is the difference between the formula of precision and recall. Okay. Now, in the following cases, false negative cases can be very costly. So, in the case of forest fire case, false negative cost us a lot. False negative means that the device is predicting no, but the reality is yes. That means that in this case, it is false negative. That means the fire can be there. False negative means that device is telling no, there will be no fire, but in reality there will be fire. So that in reality the answer is yes, but in prediction it is no. For that reason negative has come. For that reason it is false negative. And if it is false negative, then there is a very chance for forest fire, and it will cost the person, the fire people, a lot. So in the forest fire case, false negative cost us a lot. Are you getting how it is creating we have to, means the people have to pay a lot, because the device is predicting no, but in reality there can be forest fire. So in this case, if it is a false negative, so it costs us a lot and are risky too. So if no alarm is given when there is a forest fire, right? So maybe the whole forest can be burned down. So viral outbreak is also one of the false negative case. So for this case, in this reason, consider the case of COVID-19 as it spread out and the machine did not detect it. So imagine what will happen. So false negative, if it is means in this case, it will create a lot of problem for us. So now F1 score. Now F1 score is the balance between the precision and the recall. So the formula is 2 into precision into recall by precision plus recall. So this is the formula of F1 score. Now when we have 1, that means when the calculation of the F1 score is coming 1, that means 100% for both the precision and the recall. That means it is the ideal solution. It is the ideal solution. So in this case, F1 score would be also the ideal 1. That means the result is coming 1. Okay, so that is the perfect model. We can say if the F1 score, the value is coming 1, that means that device is very perfect and it is working very nicely. So as the values of both the precision and the recall ranges from 0 to 1, the F1 score also ranges from 0 to 1. So remember children, if the F1 score is coming in between, the value is coming in between 0 to 1, that means the device is very perfect and it is working very nicely, and your result is also perfect, because the F1 score perfect result is 0, in between 0 to 1. All right. So these formulas, children, you have to remember, you have to practice, and you have to by heart the situation. You have to close your eyes and think of the situation, and you can able to understand very nicely this the condition, right? So children, I think almost whole topic I have discussed of evaluation. So if there is any doubt, any confusion, you can comment me, and I will like to take to get your comments. Okay, and read the chapter thoroughly, practice those formulas, because this chapter is very, very important. And thank you and have a nice day.